We are going to be looking at the alignment for the King KN72. I handed that paper out to you, but you can also find it in the manual. Items that you will be needing for this will be a Phillips screwdriver to remove the screws in the front here on each corner. You will need an alignment tool. Plastic or ceramic will work. You will need a scope probe to put on the frequency counter. You will need a black and a red Sharpie, as well as the bigger probe for your meters. You will also need a meter face. And so I'm going to move this over just a moment so we can look at the meters. The meters are going to be different types here. And so when we work with them, you'll see that each one has some unique characteristics. The indicator I am using today is a IND 350, and you will see that on the back of the unit. There will be a faceplate, or maybe on the side of a unit where you would find it. And you'll see that this is a IN 350. It may also be an IN 351. See. So the other indicators in this classroom are going to be the IN10 or the IN10A. You'll see that that is going to be written on the side for the IN10 here. This one's a little heavier than that one. This may or may not be on it. One of them we have this ties into the back. The others all have this adapter onto the back. Another type of meter that's in the classroom is the IN41. And so it looks a lot like or similar to the IN10. However, it is a little different on the face, as you can see. It also has its coarse deviation in numbers here, where you can set your OBS. And you will see that this is going to have the plate on the back here. This is IN41A, and so you could use it. The other indicator that is in this classroom is this one. This is the AQU. It's the biggest one we have in the classroom. If I can slide it back so you can see it. So you can see the heading and the course set is here, the OBS. And the back here will have the plate on it. It also will tell you that it is the AQU here, and it has an adapter like this. Now, these adapters are not interchangeable. You actually will need to find a wiring harness for each and individual one. I'll show you. I have gotten rid of all of the meters except for the one that I'm going to be, or indicators, all but the one I'm going to be using, which is the IND 351C. And what I want to show you is the cables will be marked. They're in the KN72 drawer, but they will say KN72. But also on the same cable, somewhere, sometimes at the other end, sometimes in the middle, in blue or white normally, it will tell you which indicator it goes to. And this is the IN350 It also works with the IN351C. So these are the cables you would need for this meter. Every one of them is different, so look for the name on the harness for which one it matches. Now that we've looked at the harnesses, we're going to move it out of the way in just a moment. I'm going to tell you the test equipment that you're going to be needing. The first thing you will need is a power supply. That's going to be at the end of the room, and it's hooked up to our LA6 panel. That is the unit that allows us to power up the equipment. Our wiring harness, this end right here on that wiring harness, will attach right here on the LA6 panel. Then this will connect to the indicator, the 25-pin RS-232 will connect back here, and then we will have this connector that will attach to your KN72. Along with the LA6 panel, which will supply our power supply, you'll want to ensure that you're in the 14-volt position here. I know these cables are in the way, but 14-volt position, that's the 28. The KN72s are aligned at 14 volts. So make sure you're in the 14 volt. You will also need a generator to generate the VOR ILS signal generator. And we will come over here, and we will be utilizing the 750 to generate. So we'll be using the frequency and the bearings, the same things, same controls that we used on the IN385. You will also need a digital meter. It says a VTVM or a DVM fluke or equivalent. We will be utilizing the DVM, digital multimeter, that's in the classroom, and that's the fluke. And we will also be using the frequency counter. So we'll be using, for the test panel, it says to use the KN72 test panel. Again, we're still using the LA6. And so that's the equipment we will need to do the alignments. To do an alignment, you'll want to go ahead and take the screws that are Phillips. Let me get us down here. Out of the front, not the back. Out of the front of your converter. Just remove these, and do not remove these from the back, because all that does is take the plate off and you have to put it back. But once you do that, you can go ahead and you can slide, once you take the screws out, you can slide the converter out of the case and lay it on your mat. Do not attempt to put it on the case when you're doing the alignment, because it will actually short out the back. I'm going to roll down here so that we can get started. The first thing I want to do is connect my converter to my indicator and to my test panel. When you are connecting the connector to the converter, please ensure as you look inside here, and I know you probably can't see this very well, but all of the connectors need to be on top. They need to match to the top or the component side of the board. There should be a key that allows you to slide here. Some of them have it, some don't. But at this area right here, there's a split in the board, as you can see. So that part there should be where the key's at if it's not missing. So you want to make sure you put that in there. If you look at the paper that you were handed for the King KN72 VOR/LOC converter, it has section 6 maintenance at the top. This is the sheet you will be using. It says that I was talking about, and this will be in the manual, but you also have a copy of it because I handed it out. And so we've already confirmed the equipment. So now we're going to be starting on 6.2.2 alignment procedure. Note that it must be performed in the order that it is given to you in the book. Step A says to mid-range all pots. I do not want you to mid-range all pots. The pots that we have are 1, 2, 3, 4, 5, 6. These potentiometers are what we call 30 turns pots, and they are very difficult to get back centered where they need to be. You also have 6 more pots. I have one here that's not together, but there's 1, 2, 3, 4, 5, 6 at the front. And so I don't know if you can see those very well, but those are them. If you make certain that you always have your manual in front of you, and if you do, you will see that it gives a sheet here that has the layout of all the potentiometers and all the test points that you're going to be needing. So these are all here in the books in the classroom. So the first thing it does is says to center the pots. And I just told you not to center the blue ones with the screws on top. So I'm going to have you adjust the smaller pots, and we're just going to adjust them so that they're halfway. So we're going to do that now. And what we'll do is we will just do it like we've done before on the IN. These are the small turn ones. You'll turn and find that halfway point and go there. So here's the other one. If I can do this with you, can see it. Turn, find the stops on either side, and then pick that point in the middle. So let's do all 6 of those. The 3 in front and the 3 on top. Now I'm going to go ahead and power on the LA6 panel with the 14 volts. So again, I'm going to check it, make sure it has the 14 volts. So it's 14 and on. You can see the light lit and the meter came up to the DC voltage. When you turn it on and everything's connected, when you turn your LA6 panel on, you should see some kind of meter movement. Maybe the flag moves or one of the indicator moves some. So that should tell you that it powers up. I'm not doing it in this video. However, you should run an incoming inspection, and it is performed in the same manner that you ran the incoming inspections for the Cessna IN385A converters. The only difference will be when we set our VOR voltage or our ILS voltage coming out of the 750, where we get the DMOD at this point here. With the King radios, it is done with both in. So you'll want center frequency for your ILS, and you'll want your 30 hertz and your 9960 hertz both in when you set your 0.5 volts. Remember that 0.5 volts is RMS value, so it will be AC values for both the VOR and the LOC, or the ILS. We are connected to our AC voltmeter. We are grounded underneath the speaker. We are in the D mod. Then we are going to adjust the master mod with both signals in until we get 0.5 volts. So we'll adjust that master mod until we get 0.5. And that's where we're at. I jumped ahead a little bit because step B says to apply a 13.75 volts DC to the unit, the VOR mode. We are in the VOR mode. We look at the switch on the LA6. It is straight out. The 14 volts is what we're going to be utilizing at the end of the bench. That voltage will not be changed by you to a 13.75. We will leave it at 14. So the first thing it says is to set R196 for 8.5 volts DC at test point 8. So, I'm sorry, test point 9. I wrote on top of mine. So I want to get to test point 9. That is going to be this test point way back here. You'll see that in the diagram. And the unit the resistor I'm going to be adjusting is going to be this resistor up toward the front here. So I'm going to adjust that for the 8.5 volts DC. So I am measuring my voltage at test point 9 back here, which is right here, and then I will be adjusting this resistor up here so that I get 8.5. Once I do that, then my voltage is good to go. It is 8.5 volts DC. That will be C. D. Now it's D says set R127 for 9960 hertz plus or minus hertz at test point 8, comma, no composite applied. So that just means that I do not want the 9960 or the 30 hertz to be applied while I'm doing this. So I'm going to come in and adjust my RF from the 108.0 to 108.1. That will take that composite off. And so now I won't have to worry with it. I can go ahead and come back in here and measure and adjust R127 for the 9960 hertz. I will have my scope probe connected to the frequency counter, and so it says to measure at test point 8, which is right here. I don't know if you can read that or not, but that's test point 8. This is test point 9, test point 1, test point 8. So I will be grounding to this rail here, just onto the rail, and then I will connect my scope probe that is connected to my frequency counter to test point 8 right here. And my frequency counter, as you can see, says that I am at 9973. And so I'm going to adjust that. I'm going to back up so you can see what I adjust. And I'm going to adjust that resistor for the 9960. And that resistor is R127, which is going to be this one here, this blue one here at the bottom. Please look at your books to be sure I don't tell you, lead you astray. And we're going to adjust it for the 9960. We'll just turn it down till we get there. We keep flashing between the 9960 and the 9961, and we have it there. After you have gotten your 9960, you can go ahead and disconnect your probe and move it out of your way, and go ahead and return your LA6 panel to the 108. Turn this one back to 108, and we'll be there. So, concentrating again on the board, we're going to do the next step, which is, it says to set it's E, set R200 for maximum voltage at test point 4. It says unit with mod 1 only. So, if you look on the front of these are mod 3s, most of these. So, that one we're not going to be able to do. For units prior to mod 1, proceed to F. And says set R126 for 1.5 volts RMS at test point 4 with composite applied. So when we put the 108 back, we applied the composite. And so that's what we've done. And now we want to go ahead and see if it will adjust. Sometimes this one will and sometimes it won't. So we're going to adjust R126 while monitoring test point 4. And we're going to see what will happen. Here's test point 4. And let's see if we can change. And that's an AC volts because it says RMS. So let me change the meter to RMS. Okay. Back on test point 4. Adjust R146. See if it will adjust to 150 or 1.5. This one does not change. If you try it one way and then the other and it doesn't change, then just leave it. Don't try to change it. But sometimes E and F do not work. Other times they do. So we're going to move on to G. G says to set R140. G says set the OBS and the VOR generator to 90 degrees from. So I'm pushing the button up here And I'm going to see the 90 come over because I'm in my bearing. And I'm going to make sure I'm down into from. The meter should indicate from here as well. It's not like the IN. And we're going to adjust it to 90. And wait for the D bar to kick in, and it should come to the center. If it doesn't, it's out of alignment. So we'll need to align it, which we already knew. So what we're going to do is allow the D bar switch to timeout and center the needle with R112, which is this one in the front, in the middle. So we're going to adjust it until our needle centers. But you will have to wait for the D bar sometimes to. So we're adjusting. Like I said, sometimes when we turn, it takes a minute to move. You want to do it slow and get it centered. Give it a chance to settle down. D bar is slower than you realize. So once you got it centered there, you have done G and H. Now we're going to set the OBS and the VOR to 0 from. So I'm going to go ahead and set the OBS to 0. And I'm checking to make sure if there's any play. I center that. I then will set our 750 to 0. And it's still on from. And I will let D bar take effect and timeout. Then I will center the needle for R133. I'll use R133 and center. And that's this blue one back here in the back. So we're going to center. Okay, so now we have it centered. Kay says if you cannot get it to center on all of these, you just repeat G, H, I, and J until you get the best centering possible, so the best centering is obtained. So now ELF says set a 10-degree difference between OBS and VOR generator. I'm at 0 on both. So I'm just going to push the plus 10 here to give me 10 above. ELM says set 106 for a 150 millivolt indication. This indication is going to be taken between pins 2 and 10. So gently, do not shove these up in there. Gently put these leads into the connector. You will need the 2 Sharpies, the red one and the black Sharpie. You'll need both of these Sharpies to do that with. I am going to insert the test leads gently into the back here where these pins are at, and I will start from the right and count to the left. And this first, it'll be pins 2. So 1, 2, gently. Don't shove it in there so far that you bend those leads, those connectors. And then after you do that, it says pins 2 and 10, so you can count over. So we know we're on 2, so 3, 4, 5, 6, 7, 8, 9, 10. 10 is actually ground, and if we take a look at it, you'll see 10, 9, 10, and 11 and 12, I believe, are all connected together. But don't shove them in there so far that you mess it up. Just make sure that you get it in there where you can get your reading. And once you get them in there, we are going to adjust R106 for 150 millivolts. So we're going to go to R106 and adjust it. .106 is in the front here, all the way to your right. So we're going to get this in here and adjust it. Till we get our 105. So I'm adjusting that resistor till I hit 150. I went up a little bit too far. So there I am. It really doesn't matter how you hook your meter up. If you put the red on pin 10 and the black on pin 2, you have your positive value there. If you flip it around, let's see if I can zoom in on it, you have a positive value there. And if you flip the leads around the other way so that the negative is on pin 10 and the red is on pin 2, you'll have a negative. So red on 10 is positive 150, and black on 10 would be a negative 150. We are finished with the VOR. So we just did number M. Now we're going to N for November. And it says switch the converter and the generator to the localizer mode. Don't forget to switch your switch up here on your LA6 as well. You want to flip it. Make sure that you get this one turned, as well as changing to your frequency for the localizer of the 0.1 over here. So you want to go to 0.1 here and flip that switch. The other thing you need to make certain that you do is set your 0.33 with both your 150 and 90 hertz being applied. They both need to be there. So you're using a center frequency to actually set your 0.3 now. It is set the same way that we set the 0.5 a while ago. We'll get the AC voltmeter and go into our DMOD port, and we will take that measurement. All I did was put this on the 108.1 for the localizer frequency, and I connected my red lead to the DMM port, and you'll notice that when you do that, you come up with 3.43, or you come up really close to your 0.33. So what we need to do is come back over here and adjust the master mod until we get that 0.33. So we'll just adjust it down until we get that 0.33. And once we get there, then we are ready to go to the ILS. So I'm set at the 0.33. It keeps flashing between the 330 and 331. That's close enough for me. So we are set there, and we are going to be going to N. So we are going to switch our switch into the localizer mode there at the bottom, and we are already at a localizer frequency. We are now at O. Apply the 90 Hertz localizer tone only. So what we're going to do here is to remove the 150. We will turn it until the 150 light comes on to show that we don't have it anymore. And it says for P, set 109 for maximum AC at test point 2. So we're going to go to test point 2 and adjust R109 for maximum AC. Okay, so we're measuring at test point 2, which is going to be this point right here. There's 2 together, and you'll see that in your diagram. It'll be the very back one on the back side or on the right side, the way I have it laid out. And my voltage there right now is 0.990. So what I'm going to try to do is see if it can get bigger. So I'm going to adjust this resistor. This resistor here, which is 109 for maximum AC out. So right now I'm sitting at 0.302, and I go one way and it drops. Actually now it's going to 313, then it went to 311, so I'm going to go back. Let's see if I can hit my 313 again. Uh, 309, yeah, 313, 314, and it's flashing between one or the other. So once I get it there, then I've got that one set. The next one says, which is Q, apply the 150 Hertz localizer. So I'm going to remove the 90. So the 90 degree is there. And set one R138 for maximum at test point 4. So we're going to the other side, test point 4, and we're going to adjust R138, which is this one right here. There's 2 together here, and it's the one closest to the front. And we're going to 4 right here. And 9.75. And this one is okay, they're both up now. This one's 9.99, yeah, 0.99. This is 0.975, so we're going to see if we can adjust it and get both of them pretty close to the same.